Okay, here is Chapter 3, Part 3, final installment. We're going to talk about the four big validities. Okay, so and these will pop up throughout the semester. We have construct validity, external validity, statistical validity, and internal validity. Okay, so construct validity, this deals with how well your operational definitions are constructed, basically. How well what you're actually measuring in the experiment actually captures what you're interested in. How well does your survey, for example, actually capture life satisfaction? External validity, this is about generalizability. So think of externalizing the results of your study. Do they generalize to the larger population? Or are they pretty limited? Is the sample of participants that you have in your study, do they have certain characteristics that are very different from the larger population? Statistical validity, this is how strong the effect is. We're getting into things like confidence intervals and p-values, correlation coefficients, and also the replicability of the study. So that deals with things like meta-analyses. Is this an effect that keeps popping up over and over again? And that would, if that's the case, then that would add strength to the claim. So this deals with your statistics. Internal validity, think of the internal workings of your study. Is it well designed? Are confounds controlled for so that you can really say that the relationship between one variable and another is responsible for changes in B. Okay, that it's really A that causes B, or A that's related to B rather than some third variable. You've probably heard of the third variable problem. Okay, so you want to be able to design your experiment in such a way that you can really conclude the changes that we observe in the measured variable, the dependent variable, are due to changes in the independent variable. They're due to our manipulation. Okay. You use these types of validities to interrogate the three types of claims that we went over in the last part: frequency claims, association claims, and causal claims. Okay. So you'd ask questions like, how well has the researcher measured the variable in question? So this is where you dive into the methods section of a paper. If you're reading a paper, what did they actually measure here, and does that truly reflect life satisfaction or depression or perseverance or whatever the conceptual variable is that you're trying to investigate? Okay, when you're looking at statistical validity, it's important, and in the field is becoming more and more encouraged and required that confidence intervals, effect sizes, which we'll talk about in more depth later, are investigated, or that they're assessed. Okay, so basically perhaps a claim is made and it may be true, but it may not be a very big effect. Okay, so maybe, for example, mindfulness may have an effect on test scores, but maybe it's really not that big of an effect. So it may not really be worth the effort and the time to do a particular mindfulness intervention or whatever it is. Okay, internal validity, this is especially critical for causal claims, okay, for experiments. This isn't always relevant. For example, frequency claims, there's no causality. You're not looking at the relationship between two variables. You're only looking at one. And it's also not relevant to association claims because there's not the claim of causality. Now, some people may misinterpret association claims. Exercise and higher pay, if that's just if there's only the association investigated between those two, there was no experiment done, then causality can't be inferred, and regardless, excuse me, causality can't be inferred, even though some may try to spin it that way. Oh, you exercise, you'll make more money. But association study can't conclude that. Okay. External validity, with frequency claims, this is pretty important. You want to do your sampling very well. If you want to determine what percentage of a population has a particular trait, or smokes, for example, you're going to want to make sure, if you're trying to conclude about it, like all Americans, you need to make sure that you're sampling in such a way that all Americans have an equal chance of being selected, okay, that it can generalize very well. So it's got to be representative and random. Okay. External validity is often not a high priority for experiments and causal claims. It's definitely a concern how well something can generalize, but yeah, we'll get to how we prioritize this. But that's what external validity is looking at, how well these results can generalize to the general population. One common critique of psychological research that comes up is that oftentimes it's done on undergraduate students, and it's a valid critique. There are often anyway, it impacts the external validity of a study. Now, that doesn't mean they're not useful. They're often still quite useful in disproving theories and investigating important questions. But there's always kind of that caveat that these results might not generalize to other populations, elderly populations, different nationalities, things like that. Okay. Okay, so let's talk about interrogating causal claims first. Okay, so in order to establish causation, you have to have these three things. Okay, the first is covariance. As A changes, B changes. Okay, high levels of A go with high levels of B. Low levels of A go with low levels of B. Okay, they tend to vary together. Now, this is something that you'll observe in association claims as well, but you need to have this kind of association in an experimental setting as well. Okay, so covariance is often the easiest thing. Well, I don't know if I'd say that, but yes, you can't conclude that there's any kind of causation without covariance, even though you may observe covariance without causation, if that makes sense. Okay. Temporal precedence. So temporal meaning time, precedence meaning it precedes. You got to have the correct timeline here. Okay, so if you want to know if A causes B, then A has to come first before B. Okay, and then internal validity. This is where your experimental design needs to be really good, so that you know that any changes you observe in B can only be due to a change in A. Okay, so this is where you want to have, if you have two experimental conditions, like a placebo group and a treatment group, everything needs to be the same between those two groups except for the treatment. Okay, the pills should even look exactly the same. Okay, so that you can't explain any changes in B with anything else besides changes in A. Okay. These are some terms that you've probably come across before: independent variable and dependent variable. These are discussed in the context of experiments, at least in this textbook. You kind of see them discussed in other settings as well elsewhere, but at least for the purposes of this course, IVs and DVs, we're only talking about those in the context of an experiment. Okay, so the independent variable, that's the one that's manipulated, like which group you're assigned to. And the dependent variable is what you're actually measuring. Okay, and what you're trying to investigate is whether the dependent variable depends on the independent variable. Okay, so if you're doing a treatment group versus drug group versus a placebo group, changes in, say you're looking at a treatment for depression, your dependent variable would be depression severity, symptoms related to depression, and you're investigating whether that variable depends on the independent variable, which group the independent variable being which group the participants were assigned to. Okay, it's important to have random assignment in experiments. This is important for statistical validity and for internal validity, that the changes that you observe in the dependent variable weren't due to just how you picked the experiments. Like you don't want to be biased in how you assign and which participants you assign to the treatment group versus the placebo group. It needs to be just completely random and unbiased. If you allow participants to self-select which group they're in, that's going to lead to issues as well. So here's an example. Here's a causal claim. Family meals curb eating disorders. Okay, so here's where we start. We first need to look at covariance. Okay, so this was just a correlational study. So they did find a relationship. And I don't know all the details of this study. Not important, but the relationship was, families who who eat dinner together, they're less likely to have a child with eating disorders or something along those lines. Okay, so here we've got the covariance, those two variables, whether or not you have family meals together, and then likelihood of an eating disorder. They are correlated, they're related, they're associated, so they covary. Okay, now the next thing is temporal precedence. Okay, so here at number 2, which came first, family meals or eating disorders? Okay, and in this case, that might not have been looked at. Okay, so if you're just collecting data, asking questions like, do you have family meals together, and then is there anybody in your household with an eating disorder, then you don't know for sure if which of them came first. Okay, so this one wouldn't necessarily show temporal precedence. So internal validity, you can't really claim causality here because you don't have that internal validity. There could be a common cause for both. This relationship could be explained by a third variable, like income. Okay, so maybe those who are more likely to eat dinner together as a family have higher incomes, and they also, as a result, have more resources to reduce the prevalence of eating disorders. Or it could be the other way, right? Where maybe higher income families there's a higher prevalence of eating disorders because maybe the girls in those families tend to be higher achievers or things like that. Okay. So in this case, yeah, you can't. This is an interesting result. Still, it could be useful to know that those two are related. It might allow you to make some interesting predictions, but there's not enough evidence here to establish causality. Okay. Let's see. So construct validity, you also want to assess construct validity in an experiment. You've got to make sure that the conceptual variables you're trying to measure are well defined operationally. External validity, typically this is downplayed when doing experiments, where you're actually, because in order to have internal validity, which is a much higher priority, you typically have to have low external validity. You're trying to create very artificial environments in an experiment where somebody's sitting in a lab doing some particular task that measures just one specific thing under very specific conditions. It's nothing like you'd see in the real world. And then statistical validity, how strong is the relationship? How big is the effect? Okay, you're never going to get all 4 of these validities at once, but it depends which one you prioritize. Really just depends on what kind of a claim the researcher is making. So as I've talked about, things like internal validity is a top priority when doing experiments, but whereas external validity is a high priority for frequency claims, because that's what you're really trying to do, is generalize to a population. So, all right.